Hey everyone, today we're going to talk a little bit about momentum, what it is, some information about it, how to calculate it. So let's just go ahead and jump right in. First, we're going to look at how do you calculate the momentum of an object. Well, when we think about momentum, for our purposes, we're going to think about things moving in a straight line. So for movement along a straight line, momentum is calculated by multiplying an object's mass times its velocity. So momentum equals mass times velocity. When we think about our little abbreviations, we usually use a letter, just like speed is S, acceleration is A. Momentum is going to be a little bit different. M is already taken for mass, so they just picked a different letter. The letter P represents momentum. So when you see the letter P, you know we're talking about momentum. So the equation for momentum, which is mass times velocity, is going to be P equals M times V. So whenever you see that letter P, we're talking about momentum. P equals M times V. Memorize that. Remember that. Okay, so momentum is defined as the product of mass times velocity. The units are kilograms times meters per second. So think about it. Mass times velocity. Mass is kilograms. Velocity is meters per second. So if momentum is mass times velocity, it makes sense that it's going to be kilograms times meters per second for the units. So kg times m/s, that's your unit. It's kind of a longer one to write, but that's what it is for momentum. And momentum and velocity are in the same direction. So remember, velocity is just like speed, except it includes a direction. So if it was something like 30 miles per hour west, when you calculate your momentum, it would also include west because it would be the same direction. You're going to notice that momentum increases if mass increases, or momentum increases if velocity increases, or it's the opposite as well. Momentum decreases if mass decreases, and momentum decreases if velocity decreases. And force is also related to a change in momentum. We're going to talk about force soon, but just remember that force is involved when we are talking about momentum. And as the period of time of the momentum's change becomes longer, the force needed to cause the change becomes smaller. So the more time spent on it, the more time it takes, the less the force is required. And then one final thing here about momentum before we look at some examples of how to calculate. What is the total momentum after objects collide? So the total momentum of two or more objects after a collision is the same as it was before the collision. In other words, the total amount of momentum in an isolated system is conserved. And we call this principle the law of conservation of momentum. So think about it. You have a car going down the highway, another car going down the highway, and boom, they have a head-on collision. Think about the objects. Even though they collide, that force, boom, it may be released and pushed in the opposite direction, but it's the same amount. It's the same amount after as it was before. It's just released and sent in a different direction. And that's the law of conservation of momentum. So now let's look at a few examples. Okay, here are some examples very similar to the ones you will be doing in your assignment. Let's just read through them and we'll work through them together. So we can see at the top, momentum is mass times velocity, or P equals M times V. Sometimes they give you the momentum and the velocity, and you're looking for the mass, so that would be mass equals P over V. Sometimes they give you momentum and mass, and you got to look for the velocity, and that's going to be V equals P over M. Just pay attention to what they're looking for. So number one, let's do it. Calculate the momentum of a 0.15 kilogram ball that is moving towards home plate at a velocity of 40 meters per second. Well, if you look, the first thing it says is calculate the momentum. So we know we're looking for momentum. So P equals M times V. What's our mass? What's our velocity? In this case, mass is 0.15 kilograms, and our velocity is 40 meters per second. Okay. So if we plug this all in, P equals M times V, or P equals 0.15 kilograms times 40 meters per second. And if you calculate that out, 0.15 times 40, that comes out to be 6 kilograms times meters per second. Again, that's the unit for momentum, kilograms times meters per second. And that is your answer. Okay. Let's look at number 2 in these examples. Okay. Calculate the momentum of a 2 kilogram hockey puck moving east at 2.5 meters per second. So calculate the momentum right off the bat. It tells you we're looking for momentum. So P equals M times V. What's our mass? What's our velocity? In this case, mass is 2 kilograms. And our velocity is 2.5 meters per second. Okay. Plug it all in. P equals 2 kilograms times 2.5 meters per second. And when you multiply 2 times 2.5, that comes out to be 5 kilograms times meters per second. And that is our answer. Okay. In these example problems, which again, they're different than your assignment, but they're very similar. They're not the same numbers, but they're similar problems. I'm going to skip down to one that has you look for velocity. Okay. On these examples, number 5 says, calculate the velocity of an object that has a mass of 36 and a momentum of 6. Now remember, if we're looking for velocity, the formula changes a little bit. Velocity is momentum divided by mass. So we take our momentum, we take our mass. Mass is 36 kilograms, and momentum is 6 kilograms times meters per second. So now we just plug it all in. 6 kilograms times meters per second divided by 36 kilograms. And the kilograms cancel out. So 6 divided by 36, this is going to be a decimal, and it rounds to 0.167. And again, it's velocity, so it's meters per second. Okay. Let's do one more. Maybe let's find one that is looking for the mass of an object. And you know what? Looking through these examples, none of them ask for mass. So basically, if it did ask for mass, you would just take the momentum divided by the velocity, and you would find mass. So again, a few key things to remember is that momentum is mass times velocity. And don't forget that the letter P stands for momentum. And don't forget that the units are kilograms times meters per second squared. Okay, so find this week's assignment, do them on paper, take pictures of your work, and post them on the Google Doc in Classroom. And if you have any questions, please let me know so I can help you out. Otherwise, good luck, and let's work on that assignment.